Yes, good evening, all of you. Today we will discuss some of the previous GATE questions. So related to algorithms as well as data structures, we will see that some of the questions. So what we are going to see, let us start some of the easy questions. Let us see that. Let us see that some problems. Which of the following sequence, which of the, meanwhile you can solve it. So when I think data structures are also completed, which of the following sequence, which of the following sequence will valid heap, valid heap. So here we have a options, different options are there. You try to check with the options. Option A will be 23, 17, 14, 6, 13, 10, 1, 13, 10, 1, 12, 7, 5. So try to work out. So this is the option number A. A is 23, 17, 14, 6, 13, 10, 1, 13, 10, 1, 12, 12, 7, 5. So parallelly, you try to work out and tell me. So which of the following sequence is a valid heap? Okay. Similarly, we have some more options. These are the previous gate questions related to. I'm taking in parallelly even data structures as well as algorithms. Both these are related to same. 23 17, 14, and 7, comma 13, comma 10, 1, 12, 5, 5, and 2. Can someone please work out and tell me? So first of all, whether you know that what is a heap or not. Heap data structure. In a data structure, now tell me what is a heap. Please try to answer someone. Give me reply that whether you will know that or not, or you don't know the concept, so that I will explain. If you don't know, I will explain. Otherwise, you tell me. So we will see some more questions. 23, 17. Parallelly, you try to work out if you know, or if you don't know, I will explain. Don't worry. 17, 14, 6, comma, 13, comma, 10, comma, 15, comma, 7, comma, 12. Maybe 23, comma, 17, comma, 14, comma, 7, 7, 13, 7, 13, 13, comma, 10, comma, 1, 5, comma, 6, comma, 12. Just try to work out and tell me which of the following is the valid heap. So it's just asking only a valid heap, whether it may be a max heap or it may be min heap. So we know very well that what is a heap. Heap is a data structure. Heap is a data structure. So what we use is we have a min heap as well as a max heap. We will have a min heap as well as max heap. So max heap means what? The parent should be, what is the max heap means? Can anyone tell me? Max, what is the max heap? What is the max heap? Give me answers. What is the max heap? Max heap is parent, parent node, parent node should be greater than, parent node should be greater than, parent node greater, greater than, parent node should be greater than children. Parent should be greater than the children. So that is the importance of the just max heap. If it is a min heap, minimum min heap. What is the min heap means? The parent node should be parent should be less than parent should be less than children. So this is a max heap as well as a min heap. So example of let us take the max heap. So in order to solve this question, basic you should know these things. That's why I'm explaining. What is here? In order to solve max heap, so let us take example. I'm entering some elements. 14. So I am entering some elements here. Basically, this max heap or min heap will it follows. It's one of the binary structure property. Binary structure means what? Binary search tree. So basically, the elements will be stored here. Or we can say, basically, the binary, this is the heap for, basically, if you don't know what is a basic heap, let me explain that. So this is a max heap means parent node should be greater than the children. Min heap means these are the two things important. Parent node is greater than the children. Min heap means parent should be less than the children. So this is what concept. And this and one more thing is this heap is satisfying structuring property. It will satisfy the structuring property as well as ordering property. Structure property as well as ordering property. Example. So this all the sequences will be normally, what is a ordering property? So here it has to maintain. So structuring property means it should be a first complete binary tree. First of all, it is a complete binary tree. It's a complete binary tree. Sir, what is a complete binary tree? Can anyone tell me? Complete binary tree. What is complete binary tree? What is complete binary tree? Can anyone tell me what is a complete binary tree? Because just in order to know that heap, we should know all the what is a complete binary tree. Then only we can understand that how the elements will be stored. That's why I'm explaining this all the concepts. You tell me what is a complete binary tree? I will explain. Okay, I think you may not know the. I think so. Let me explain that what is a complete binary tree, and we have a full binary tree. What is a full binary tree and what is a complete binary tree? These all are very important for the objective type and match the following questions, match the following in the GATE exam. So let us see that we have a tree like this. Okay, I will explain what is complete binary tree first of all. So we have a some elements. I'm not writing this elements. This is, let us say, this is a nodes. we have nodes like this. Okay. Nodes will be like this. Now this is a complete binary tree because you see here, it is a complete binary tree. First, we have come up with this first node and we will write the nodes. So whatever these nodes you have to write in form of, array format. So that means suppose if it's a, let us take element will be 1, let us take 2, 3, let us take 4, and it is take 5. So what are the elements that are storing? Here it is a 1. It will be stored like this, sequence wise in a heap. 2 and 3. Level by level it will store. It will store level by level. What is the first level? This is the first level. And what is the next level? This is the next level. And what is the next level? This is the level. So 4 and 5. Okay. But we don't have a 3 childrens, but it is a complete binary tree. Sir, what is not a complete binary tree? Let us see that so that you will understand more. What is not complete binary tree? Which one I can say it is not a complete binary tree? So let me explain. Let me explain that example. This is, I can say that, I can say that it's a complete binary tree. It's a complete binary tree. So then which is not a complete binary tree? So let me go for the concept. So this is a, let us take one node and this is a one node and this is node. Suppose, okay, if this is a node and it should contain immediate node, but actually, so let me see that we have this one and this one. Now let us some nodes, okay, it may be one, it need not be, any ordering, I'm giving just random numbers, okay, 1, 3, 5, suppose 6 and 7, 8. Now what is it should follow like it has to sequence. Now let us see that what is ordering here, what order should follow. So 1 in the first level, 1 will be stored, and the next level we have a 3, 5. So 3, 5 will be stored. Let us store 3, 5. 3, 5 is also stored. And you see that coming to the next second level. Now third level, you come to third level, you see here. What is the element? Here it is a 6. But again here, there is a right child is missing. The right child is missing. So it is will have a empty space. Okay. After that empty space, it again storing 7 as well as 8. So this is not a complete binary tree. This is not a complete binary tree. Now this is not, this is very important. This is not complete binary tree. That is not complete binary tree because here the element is missing. Okay. So in normally complete binary tree, it will follows level by level in array format. So if anything is missing here, so then it is not a complete binary tree. Suppose, I hope you understand. So what is a complete binary tree and what is not a complete binary tree? Suppose Example, one more way, one more tree. I'm going to explain. So one more tree I'm going to explain. Let us see this. Let us take one more tree. So this is like one node, and this is one node, and this is one node, and we have it this node like this, like this, like this, like this, and we have a main only one. Okay. Now tell me whether it is a complete binary tree or not. So this is a complete binary tree or not? This is the given binary tree is a perfectly complete binary tree. It is a it is also complete binary tree. How you see here. Now let us take this one. It is following, it is storing elements in array. Let us take one and giving two, three, four, node numbers, five, six, and seven. And again, one more thing is eight. So here it is storing in level by level. What is first level? One. And second level, 2 comma 3 and 2 comma 3 and here 4 and 5, 6, again 7, as well as 8. Okay. So maybe after that it will have a empty, no issue. Okay. Because these are 4 children, 5 children, 6 children are not present. But what is in the complete binary tree, it is saying that in middle it should not empty. Suppose, so if suppose if the 5 is missing, then we can say it is not a complete binary tree. Okay. So in middle it should not miss. So now I can say this is a complete binary tree. The last elements you can keep empty. Now suppose if you add this one more element, 9. Now this is also a complete binary tree like this. You add just only here 5, one more node like 10. This is also a complete binary tree. Only thing is in middle it should not miss. Suppose if you are not adding without adding 5, suppose you have added like here in the node you are added. Now this is not a complete binary tree because these 6 children are missing and 5 children are not completed. So without this middle, without adding this middle, it should not add in the last. So now I can say this is not a complete binary tree. And suppose, sir, what is a full binary tree then? What is a full binary tree? It is not a full binary tree now. Now it is not a full binary tree. Now I can say this is a full binary tree. So this is also not a full binary tree. Full binary tree means yeah, every children, every node should be filled, should be explored completely. Now tell me, now what is full binary tree? You see, full binary tree. Just now we have seen that complete binary tree, but so immediately we need to know what is full binary tree also. Now full binary tree is just, so I can say this is a full binary tree. Suppose if I explore these children's, this is a this is the complete binary tree. Suppose if up to here, it is a complete binary tree, but not a full binary tree because in this node, it is not exploring. Only one node is explored, but one node is not exploring. So this children's also should be there. Now I can say this is a full binary tree. Okay, this is a full binary tree. Suppose if you add one more thing, one extra, now it is not a full binary tree. So this is a full binary tree as well as complete binary tree also. Every full binary tree is a complete binary tree. Okay. Every full binary tree is every full binary tree is complete binary tree. Complete binary. Every full binary tree is a complete binary tree. But it is every complete binary tree. It need not be a full binary tree. Again, reverse is not true. Every complete binary tree. Every complete binary tree need not be full binary tree. Full binary. So this is something about this by seeing the structure as well as order. So we can say that heap is it follows complete binary tree structure. That means it's a structuring property as well as ordering property. So this is what. So we can say that complete binary tree is filling level, but except the last. Last one is it's a choice. So this is what complete. Now, can anyone tell me in the gate point of view, what is a maximum number of nodes in complete binary tree whose height is h? Whose height is h? Let us take h. Okay. What is a maximum number of nodes? What is the maximum number of nodes? Can anyone tell me? Maximum number of nodes in a complete binary tree of a height h. This is one of the gate question actually. Maximum question is here. Actually, we have the question here. Okay. So in order to solve that question, we need to know a complete binary tree. That's why I'm discussing. Now tell me. So tell me what is the maximum number of nodes? Maximum number, maximum number of nodes, maximum number of nodes, maximum number of nodes in complete binary tree, in complete binary tree Incomplete binary tree whose height is whose whose height is whose height is h, whose height is h. Can anyone give me answer? There is a height of the tree is what is the maximum number of nodes possible? What is the maximum number as well as minimum number also you tell me. Minimum number of nodes as well as maximum number of nodes. Just see that. Let us see that whether it is a complete binary tree or not. This is a complete binary tree. Now, what is the height of here? What is the height of this tree? Height of the tree is what is the height? This is a 1 as well as this is a height. Height means here you can say that number of edges. Now you tell me in this one, what is the maximum? Now this is a maximum. So how many elements are there for that? We have a height will be Chapandi. What is the maximum number of nodes? Maximum number of nodes in this complete binary tree. Count chase Chapandi at least. Count and tell me. Here height is 2. This complete binary tree. Let us take this a complete binary tree as well as a full binary tree. Okay. So you see here h equal to height equal to 2. Height equal to 2. Now how many nodes we have? 1, 2, 3, 4, 5, 6, 7. 7 nodes, right? Okay. Seven nodes. Suppose minimum nodes means so I can say if I remove these 3 nodes, then I can say it is a minimum only, right? Still it is a complete binary tree only. So this is a 1, this is a 1, and this is a 1. And if you add this node, we can say this is a complete binary tree only. So minimum number of nodes of height to how much? So if it is this is a maximum number of nodes. Maximum number of nodes as well as here minimum number of nodes. Now in the minimum number of nodes, so of height equal to 2. So how many nodes are there? Count and tell me. 1, 2, 3. This is a minimum, right? So if I add this one, I can say height of 2. So what is this one? 4. Yes or no? So like this you can derive. Like this you can try to derive. What is the formula? Tell me. Height equal to suppose 3. How many nodes? How many minimum number of nodes are there? How many maximum number of nodes are there? Answers chat box lo cheppalandi. Height equal to next. Height equal to 3. What is the minimum number of nodes in a complete binary tree? What are the maximum number of nodes? Minimum how many? ఇవన్నీ possible gate questions. Height equal to 3. What are the maximum number of nodes? What is the maximum number of nodes? Maximum nodes. Height equal to 3. What is the minimum nodes? So that you can try to, we will derive the formula if you do like this. చాట్ బాక్స్ లో ఒక్కళ్ళు కూడా ఆన్సర్ చేయరా? ఆన్సర్ చేయాలి కదా. Now I already derived. If height equal to 2, the maximum number of nodes are 7. Minimum number of nodes are 4. Height of 2. Suppose if the tree height is 3, what is the minimum number of nodes and what is the maximum number of nodes? Let me draw the tree. If you are not giving answers, means I will explain again from basic. So what is the minimum number of nodes? Height equal to 3. So this is how anyway it should be filled. This is height of 1. Next, height of 2. Height of 2. This is height of 2. Next, height of 3 means, so minimum. Minimum is, now I can say this is a complete binary tree, right? This is a complete binary tree. So 1, 2, 3 height. How many nodes are there? 1, 2, 3, 4, 5, 6, 7, 8. So if your height is 3, minimum number of nodes are how many? 8 is answer. Maximum number of nodes are how many? Maximum number of nodes. Maximum means you should fill all the nodes, right? So maximum possibility here. This is these children, left children as well as right children. And here also I can fill left children as well as right children. Here also I can fill left children as well as right children. So how many number of nodes are there? So this is the first 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. How many nodes are there? Maximum possible nodes are how many? 15. In general, now tell me at least, in general, what is the formula? What is the minimum number of nodes in a complete binary tree as well as maximum number of nodes in a complete binary tree of a height h? This is one of the gate question. Minimum number of nodes as well as maximum number of nodes in a binary tree, complete binary tree. So what is the minimum number of nodes? Cheppandi. Can I write this is here? Minimum number of nodes. So what is the height 2? So can I write 2? Can I write 2 power h or not? Can I write 2 power h? Height, the h anta 2. 2 square, it will becomes 4. So here can I write 2 power? It is also 2 power h. What is the height? 3. It's a 2 cube. So I can say that minimum number of nodes in a complete binary tree is minimum number of nodes in general, minimum number of nodes in complete binary tree, in complete binary tree, in complete binary tree is 2 power h, is 2 power h. Binary tree is 2 power h. What is h here? H is a, what is h? Where h is, where, where h is height of the tree, height of the, height of the tree, where h is the height of the tree. What's the formula for the maximum, Andy? Same. Maximum number of nodes in a complete binary tree. Maximum, maximum number of nodes in complete binary tree. What is the maximum number of nodes? Will be, what is the in general formula? 2 power, you see here, of height h, height equal to 2. What is the maximum number of nodes that are available? 7. You see here, 7. So can I write like this? Can I write this formula? 2 power, what is this answer? 2 cube minus 1, right? 2 cube minus 1. 2 cube minus 1. 2 cube means 8, 8 minus 1, 7. This is also, you tell me, 2 power 4 minus 1. 2 power 4 minus 1. So, ante enti? So, height equal to 3. That means 2 power, what is the formula here? 2 power h plus 1. 2 power h plus 1 minus 1. This is a in general formula. So minimum number of nodes are of a height h is 2 power h. Maximum number of nodes of a height h is 2 power h plus 1 minus 1. So this is what complete binary tree. I'm taking one concept and I am explaining all the possible gate questions. Okay. So now in this, you will have a multiple questions on the single concept, that is a complete binary tree. So what we have discussed, what is complete binary tree? We have a chances of asking questions for the matching of questions. So they will give you that what is the complete binary tree, full binary tree. They will give you some description. Okay. And one more possible question is, what is the maximum number of nodes that are possible of height h? So maximum number of nodes that are possible in a complete binary tree is 2 power h plus 1 minus 1. So this is answer. And minimum number of nodes of a complete binary tree is 2 power h of a height h. 2 power h. These are the two possible questions from the complete binary tree. Now tell me maximum height of the complete binary tree. So there is a one more question. What is the maximum height of a complete binary tree? Is maximum height of a complete binary tree. Maximum height of a complete binary. This is one more gate question is, what is the maximum height of the complete binary tree? Can anyone answer? Maximum height of the this complete binary tree. There are good questions that are possible date actually. Tell me what is the maximum? Maximum height of a complete binary tree. Options. Maximum. Maximum height. Height of complete binary tree. Complete binary tree is choices. Option A. Option A. Option A. N. Order of n. Here it is. Options. We have options. We have options like order of n. Option B. Order of 1. Option C. Order of log n. Order of log n. Order of log n. And option D. None. Option D. None. Tell me which option is correct. Very good. So maximum that the height of the complete binary tree is absolutely it's a log n. Very good. So this is the height of the complete binary tree. Option C is correct. Perfect. Someone has given answer. Next, like this, you can give answers. So, so let us try to now. That means in order to construct a heap, first of all, it is a complete binary tree. First of all, should be a complete binary tree. It has to follow the ordering property. But what is the condition? If it is a max heap means the parent value should be greater. So min heap means it should be minimum. So let us take one more example of understanding min heap as well as max heap. So min heap as well as max heap. I hope you understand what is a complete binary tree as well as full binary tree and how to calculate the height of the complete binary tree as well as. So actually in GATE exam they are not bothering about uh, questions on theory. So they are just application type. So like this, the application type of questions will be possible. If GATE is always it will not they will not ask only simple questions. The concept will be tested in application point of. Application means not where it is used. So they will application means no, they will just test the knowledge completely. They will not ask directly. If you know complete binary tree, so we can find out the height of the binary tree as well as a maximum number of nodes as well as minimum number of nodes. They will give the generalized formulas. They will not ask, simply what is complete binary tree. Just only for, matching parentheses for those type of questions, they might give you, but the remaining things, they will not give you this much, easy questions they will not give you. So they will always ask here, this type of questions application. Now I just tested, right? I generalized the formula 2 power h, 2 power h plus 1. Like this, they will ask you questions. Okay. Not only this concept, any concept in algorithm as well as the data structures. Like, so let us take min. I hope you know what is the max SIP and min. Parent should be greater than the children now. Okay. So let us take, I am giving some numbers. You try to arrange whether it's a, so that we will go for that question. Okay. 14. There are some elements are there. I am giving 14, 14 comma 8 comma 10. Randomly, I'm giving some numbers and we will try to arrange in a max heap. Heap means either it may be min heap or max heap. Now 5 comma 7 and 9. So there is a concept of heapify. Suppose if the elements are not in, it is not maintaining heap property, then we will try to adjust those elements. We will try to adjust elements. That is the process of heapify. Suppose, let us take first 14 is the first level. What is the first element here? You take this order. 14 is the first element. Now, we need to just construct ordering property. We can go for the order wise. 8. But while you are adding this any element, you check whether it is satisfying the heap property or not. Now, what we are trying to see here, it is a max heap. We are searching for the max heap. Now, check whether this is a max heap property or not. Or well constructed. If it is not, you can heapify that. So 8, 10. So in max heap, what is the condition? Parent should be, what is the condition? Max heap. In max heap, the parent should be greater. Here, parent should be greater than the children. Parent should be greater than the children. This is the basic condition. So now max heap means, you see here, 14, 8, 10. We need to arrange order wise only, okay, without searching anything. We just arrange. That is why ordering property. 9, 3, as well as 3, 5. 3, 5. Again, 7, as well as 9. You check here. These two are what they are following. So this is the root. Parent should be greater than the children. Yes, it is okay. Now here also parent should be greater than the children. Very good. Now here also 10 is greater than the children. 7, 9. So now I can say that this is a max heap. The sequence of elements are following max heap property. Max heap property. Okay. Similarly, so this is, I hope you understand what is a max heap. Okay. This is what max heap. Parent value should be greater than the children node in the tree. And it has to follow the ordering sequence. Okay. So now this is I can say the sequence is following max heap. Max heap. Okay. Next one is min heap. You see here, next one is min heap. Now let us try for the min heap. What is a min heap means? Min heap means what? Tell me. Already చెప్పాను కదా. What is a min heap means? Parent should be less than the children. Parent should be less than the children. That is a min heap. That is a min heap. సో ఇప్పుడు ఈ కాన్సెప్ట్ చెప్పిన తర్వాత ఇలాంటి క్వశ్చన్స్ మీరు ఎన్ని క్వశ్చన్స్ వచ్చినా చేయగలుగుతారు. ఇట్ ఈస్ నాట్ ఎ బిగ్ డీల్. వెరీ గుడ్. Parent. So now you tell me here. I'm giving some sequence, okay, some sequence of numbers. You try to tell me whether it is a following a max heap property or not. I am writing some sequence 2, 11, 8, 8, 11, 8, as well as 10, 10. Some randomly I'm taking 9, 11, 10, 13. Okay. Let us try to see this is whether it is following min heap or not. So what we need to do? We need to start from the first one. 2 is the root node and a sequence 11. Next element is 8. Next element is 8. Next element is 10. Next element is 10. Next element is 10 and 9. And here 11, 10, 2, 11, 8. After 8, it is 10, 9, and 11, it is 13. So I am trying to check for the min heap, not max. Min heap. What is the min heap, Andy? Min heap. Min heap means I already explained what is parent should be. Parent should be lesser than child. Less than the child. Less than the child. So now tell me whether it is following a min heap property or not. You check all the elements and tell me. Here first, it's a parent is 2. Both the children 11 and 8 are no. So okay, here it is following. Now here parent is from this one 10. You tell me. Here also 8 is parent should be less than the both the children here. But you see here, it is what? 11. Parent is 11 as well as here. What is the 10, 9 here? Is it satisfying here? Parent is less than the children. The condition min heap property is satisfying. No. So I can say that this sequence is not, this sequence is not uh, satisfying the min heap property. Here it is failed. Here it is failed. So what we will do, we will do that heapify process, you know, in order to maintain the heap property. So that we are not, we will just, theory it is important, but maximum. It's a, I can say that it's not a min heap. So we can say that it is not satisfying min heap. So it is not a min heap. So if you want, do some modification, you do the heapify process. Okay. Heapify process, you can try to bring. So what you can bring at that time, you can place that 9, you can place to the in place of 11, and 11 you can bring into in place of 10. So that is a heapify process. You have to make this as a min heap. Okay. But we are not worrying that much. So I hope you understand what is a min heap and what is a max heap. Now we will solve this question. Now you tell me which of the following sequence is a valid heap. Uh, you please try to work out and tell me. So please try to work out and tell me this question. This question is which of the following is a sequence will be the valid heap sequence. ఎవరైనా ట్రై చేయండి, ఆన్సర్ ట్రై చేయండి. నేను చేయాలా లేకుంటే ఓకే. I hope I have explained the heap, right? You just try to work out and tell me. First sequence is a valid or not. Whether it may be okay. You might be wondering that which is heap means, suppose if they will not mention any min heap or max heap means, by default anything you can consider whether it may be min heap or max heap, because if they will not give, if they mention only heap, so whether it may be min heap or max heap, anything is okay. So whether it's a valid sequence or not. Which of the following is a valid heap? Okay. Option B. Yeah. Okay. Someone is telling that option B. So remaining all people, you try to work out and tell me. So it's a 23. 23 means it's a higher root node. 23 means it's definitely it is a what type of heap? It's a max heap. It should be 17 and it should be 14, and after that a 6. It's okay. After that you try to check 13. If anything is failed, you stop there itself. Okay. 13, 6, 13. After here, after 13, it will be 10. Okay, it is less than 14. After 10, it will be 1. After 1, again, it is a 12. I think here it is failed. Okay, 12. So parent is a 6, here it is a 12. It is not maintaining maxi property. So A is a wrong option. A is wrong option. So that means, I mean, which of the following is valid heap? We are just searching for the valid heap, not for the. So similarly, you try for remaining options also. So those who are completed, you try to analyze that. Suppose if I want to insert a key into an empty heap, what is the time complexity it will take? ఎవరైనా ఇది కంప్లీట్ అయిన వాళ్ళు ఖాళీగా ఉండకుండా యూ ట్రై టు యునో టెల్ మీ. సో ఇన్ ఆర్డర్ టు ఇన్సర్ట్ ఏ కీ ఇంటూ an empty heap, what is the time that is taking? What's the time complexity that is taking? And second one is ఇంకొకటి to insert a key in its proper place into already constructed tree. In the worst case, what is the time it will take? Already there is a, we have constructed tree. So suppose I want to insert a some element. What is the worst case time complexity it will take? So these are all possible questions. Okay. Can anyone you just work out and tell me? Meanwhile, uh, okay, here it is actually taking much time. Okay. So tell me, here it is. What is the sequence? 23. 23 is there. And B option here 17. That is no issue. And 14, I have no issue. Here, again come to here, 14 after 7. It's okay, parent is greater. And 13, it's okay, parent is greater. In this 14, here let me be 10, parent is greater. And here 1, parent is greater. After 1, it's again 1. After 1, what is it is again? 7, it is a 12, right? Option B and wrong. So here again, parent, here 12 is coming. Whenever 12 is coming means what? Parent should be greater, but what is here? 7 is there. No, it is not correct. Okay. So here 10, this is violating. So this option also wrong. And let me check for the one more option, C option. Option C. 23, 17, 14, and I'm constructing here 6. Here 6. 6 is okay. And here 13. 13 and 10. 10 here. 13, 10. Again 15. 13. Again 7. Here 7. 7 means what? Here parent is, again it is also failed. Parent is lesser value. Okay, here also this option has also failed. Okay, next 23. Let us take one more sequence, D option. 23, 17, 14, 6, 6, 13, sorry, 23, 17, 14, and after 14, it will be 7. After 14, it will be 7. After 7, it will be 13. 13, it will be, after 13, it will be 10. 10, 10 after 1, 10 after 1. Again, it will be 5. This is okay, 5. Because upper level is 7, parent is greater. 5, and here 5, it is a 6. This is also okay, good. 6, 6 after it is here. What is the sequence? 13 kada. 13, 6 after it is a 12. Perfect. So parent is greater than. Option D is right. Option D is correct. So which of the following is a valid max heap means option D ma. Okay. Not B, maybe you missed some element. Option D is correct option. So this is a following sequence. Now tell me. Now I have asked the question. One more question, that is, what is the question I have asked? Suppose, I will write clearly here. I want to insert key. Okay. So what is the time complexity that we will take? I want to first insert a key element into an empty heap. An empty heap is what is the time complexity? Time complexity. An empty heap is time complexity. Time complexity. Tell me, anyone? If it is an empty heap, what's the time complexity it will take? In order to insertion. It is directly right. Order of 1 kada. Order of 1. Because if it is empty heap means it will take only order of 1. Order of 1. Suppose to insert a key, next, the second one is, suppose to insert the key in its proper place. Proper place, not just for insertion. Try to understand. Okay. To insert the key in its proper place into already constructed tree. Already constructed tree. Already constructed tree. In the worst case. In the worst case, and in the worst case. In the worst case, what is the time complexity? చెప్పండి. What is the time complexity? In worst case, to insert the second point, okay? To insert a key in its proper place into already constructed tree. In the worst case, what is the time complexity? It's not only just for insertion. Maybe suppose if it is not in a correct place, we should place in a correct place. Suppose we are constructing a max heap. Suppose it is not in a proper place. Suppose what we need to do, we need to perform the heapify process and we need to place that element into in its correct place. Worst case, how many, you see here. So basically, the heap is a complete binary tree. It's a complete binary tree, right? So maximum, how many moves you can perform? Maximum, how many swap operations or move operations you can perform? Suppose, what is the maximum? Suppose if element is I have inserted, suppose here. Suppose the element is not in its correct place, example. So maximum, how many moves you can perform? This element you can send to here and you can send to here. Yes, sir. These are only possible swapping operations, right? So maximum possible swapping operations will be maximum. What is the time it will take? Now tell me. Order of n is not correct. It is order of n, that is a normal list. List or arrays, it will take order of n. Now it is a heap. It is maintaining structure property as well as ordering property. That means it's a complete binary tree. It's complete binary tree. So maximum you can move how many levels? Height of the binary tree, right? Maximum you can move height of the binary tree. What is the height of the binary tree means? What is the maximum height of the binary tree that is possible? Already we have discussed. Maximum height of the binary tree is చెప్పండి ఆల్రెడీ చెప్పారు ఇందాక. That's it. If it is the maximum order of the binary tree is maximum height of the binary tree is log n, right? Log n. So maximum you can perform height of the binary tree operations. Suppose the height of the binary tree is like this. We have like this. So maximum how many moves you can perform? Suppose if it is not it is an invalid choice, you can move this to here, or in worst case you can move here, or in worst case you can move here. You can move up to the root node. When you will have a up to root node, suppose the element is suppose I entered maximum element here. Suppose maximum element is you inserted at the last position. Now in the worst case, this maximum element can move to the root node in a max heap. In a max heap. That's it, right? So how many swapping operations are how much time it will take? Maximum height of the binary tree. Height of the binary tree we know it is a log n. So here also answer is to insert in its key in its proper place already constructed a tree. In worst case time complexity is what? It is order of log n. Order of log n. Order of log n. This analysis is very, very important in algorithms and data structure. So this analysis, it will plays a vital role. Okay? So like this, the questions in heap heap tree will be possible. Suppose, Inka, let us take one more question also. One more question. Suppose I want to perform one more operation, that is to delete, to delete, to delete, to delete, to delete a root node, to delete in a heap only. This all are I'm asking. To delete a root node, to delete a root node by replacing, let us take, by replacing, by replacing with the, by replacing with the last leaf node, last leaf, last leaf node, last leaf node, and adjusting text. Okay. What's the time to delete a root node by replacing with the last leaf node? What is the time complexity? What is the time complexity? Tell me. What is the time complexity? Can anyone tell me? I want to delete a root node. Okay. So that root node, I need to replace in the last leaf node. Leaf node, last leaf node. Okay, this one, last leaf node. So what is the time that it will take? These analysis are very important అండి. ఇవే మనం నేర్చుకోవాలి. This analysis. Okay. Suppose you want to replace with the root node, that means what? With the leaf node. So what is the maximum time it will take? That means that this leaf node, it is going to root node. You are deleting the root node as well as replacing the last node. So maximum what you will do? You will check for the this node. You will swap with this node. Again, this node you will compare here and you can swap this here. And you this node, this will be swapped and you can compare here. Maximum operations is how much? It is also taking log, and it is also taking log n. So order of log n time. Order of log. So this is what this analysis of the heap sort. Okay, maximum the questions will be possible questions are this in heap. I hope I have covered all the heap. So let me go for the some more one more tree. I have a binary search tree. I think like this, they can ask any questions. Okay. But if any swapping performance, any swapping operations or anything, okay. So maximum it will take log n, okay, because it's a heap tree is a complete binary tree, so it is strictly following the structure, okay. So let us go for the one more possible questions in gate. The questions will be, lot of questions will be asked in binary search tree also. Binary search tree. Can anyone tell me what is binary search tree first of all? Simply, in simpler way, you tell me. What is binary search tree? Binary search tree. Binary search tree. Please, can anyone just share your answers? Okay, I will tell you. Don't worry. Binary search tree means binary search tree means. So here the elements will be entered. See, here root node is there, and we have a left child as well as a right child. We have a left child as well as right child. The left child should be less than the root node. The left child is less than the root node, and here right child is greater than the root node. Right child is greater than the root node. Root node. This is a left child. This is a left child as well as this is a right child. And this is a root node. This is a root node. This is what? Root node. This root node, the left child is lesser than the right child. Now you tell me. This is what? Binary search tree. This is the basic idea of the binary search tree. Suppose in this also, the possible gate questions are, first they will give you elements. If they want to ask you, level 2 questions are like this, they will give you easy one. They will give you all elements and they will ask you arrange the in a binary search tree. Suppose I will give you 20 and 10, 9, 25, 36, 29, 5, 12, 3. Let us take this is a elements I need to arrange in a binary search tree. These all elements I should be arranged in a binary search tree. So now let us write here clearly. So first element is 20. The 20 comes here. The 20 and 20. Next element is 10. So next element 10 is less than the 20 or not? Yes, less than the 20. Yes. Okay. Next element is 9. 9 is again less than the 10. Less than the 20 as well as less than the 10. So this is 9. And 25. Now you see here next element is 25. The 25 can be inserted. 25 can be inserted here. 25 can be inserted here. And next 36. Is 36 is greater than the 20 or not? Yes, it's a greater than the 20 as well as greater than the 25. So it should be here 36. 36. Again 29. 29 is greater than the 20 as well as greater than the 25, but less than the 36. Is that right? But less than the 36. Less than 36 means it will be left child. So it will be 29. 29. And the next element is 5. So now this 5 5 is less than the 20 and less than the 10 and less than the 9. So it will come here 5. So this is a 5 will be placed here. Now there is an element that is a 12. 12. Now this 12 is less than the 20, again greater than the 12, greater than the 12, greater than the 12. Now again the element is 3. So 3 is less than the 20, less than the 10, less than the 9, less than the 5. So it will be placed here. So this is a binary search tree. Binary search tree. Binary search tree. So now here also we have a binary search tree. We can apply searching an element and the insertion will be allowed. What are the operations that can be performed here? We can perform the searching an element in the key in the tree, as well as I can insertion I can perform, as well as a deletion I can perform. I can perform the deletion as well as searching, as well as insertion, as well as deletion. All the operations I can perform. Now I want to analyze. I want to analyze this. Okay. In general, what is the time complexity? So wise also I will generalize. Okay. So let me first you how to understand what is a binary search tree, and after that how we need to enter an elements into a binary search tree, and suppose how we can perform the insertion operation. We have seen that. Now how we need to perform the deletion operation. So deletion operation, how I need to perform. Okay. Suppose here also I will tell you, listen carefully. In the deletion operation, we have a different cases. Suppose if you delete the node 3, it is a leaf, right? If you delete the node 3, you can simply delete the 3 because it is not impacting anything. Suppose if you are deleting a internal node, even leaf nodes and okay, these are all called leaf nodes, and this is a root node, and remaining all are, we can say that, internal nodes. This is also leaf node, and this is also a leaf node. Okay, these all are leaf nodes. If you delete the leaf nodes, you can simply delete that leaf node. It is not impacting anything on the tree. But if you delete any root node or any internal node, you cannot simply delete, right? Because if you want to delete 20, can I able to delete simply 20? No, it is, you need to reconstruct the tree, because the tree should be again, you have to maintain properly. So for that, we have a two conditions. We have a two conditions. Suppose, let me explain that. I want to delete, I am deleting a root node. Suppose I am deleting a 20. If you are deleting 3, I don't have any problem. Suppose if you delete the 29, I don't have any issue. But suppose I have deleted a 3. Let me check for this. 3 is deleted. This 3 is deleted. Okay. Now go for here 20 now. Now in the second, I have deleted 20. But if you delete the 20, root node you have to replace. Okay. I need to replace the root node. Who I need to replace the root node. రూట్ నోడ్ని ఎలా రీప్లేస్ చేయాలి? ఓకే, ఎలా రీప్లేస్ చేయాలండి రూట్ నోడ్ని? బికాస్ యూ ఆర్ డిలీటింగ్ ఏ లీఫ్ నోడ్, I don't have any issue. But if you are deleting the root node, you should replace this 20 with some other element. 20 with other element. Then only we can say that this will be correct manner. సో 20 డిలీట్ చేస్తే నేను ఫస్ట్ ఏం చేయాలి? ఏ నోడ్ని నేను I have to make as a new root node. ఫర్ దిస్, దీనికి ఒక షార్ట్ కట్ ఉందండి. ఎప్పుడైనా గేట్ ఎగ్జామ్లో కానీ అడిగినప్పుడు క్వశ్చన్స్, ఇలాంటి క్వశ్చన్స్ అడిగినప్పుడు ఇమ్మీడియట్గా మీరు ఒక షార్ట్ కట్ గుర్తుపెట్టుకోండి. ఓకే, సో వెన్ ఎవర్ యూ డిలీట్ దిస్ రూట్ నోడ్, జస్ట్ నేను చెప్పే షార్ట్ కట్ గుర్తుపెట్టుకోండి. జంప్ లెఫ్ట్ అంటే రెండు పాసిబిలిటీస్ ఉన్నాయండి దీనికి. ఓకే, వెదర్ యూ కెన్ రీప్లేస్, you will have a two choices, whether you can replace left side as well as right side. Okay, jump right, jump right and go on left side. Okay, jump, you see here, and what is the least element here? So jump right here, go on descendant. So you see, suppose you will have a clarity. These are empty nodes. This is also empty node. Okay, so what is a node you have to replace these first? This is a root node, so you don't have any descendant. So so you see here, you go on descendant, not right side. So you have to go on descendant. What is a descendant here? Only there is a right side is there. No, right side I cannot go here. So you have to go here, go on descendant. And I mean left side. Jump right and go on left side. అంటే ఏంటి? లెఫ్ట్ సైడ్ ఏమైనా ఉందా అండి? ఏముంది? ఇంకేం లేదు, ఓన్లీ 25. సో దిస్ ఇస్ ఏ 25 you can replace. No issue, I don't have any issue. So in place of 20 you can place 25. Or ఇంకో చాయిస్ కూడా ఉందండి. ఓకే, you jump left, left side jump చేసి you have to search for the right hand side element. దీన్నే ఇన్ ఆర్డర్ ప్రీడిసెసర్ అండ్ ఇన్ ఆర్డర్ సక్సెసర్ అంటారు. ఓకేనా? సో నేను చెప్పే షార్ట్ కట్ గుర్తుపెట్టుకోండి, మీకు అంత అవసరం లేదు. సో హియర్ జంప్ లెఫ్ట్ అండ్ గో ఆన్ రైట్ సైడ్. ఓకే, లెఫ్ట్ సైడ్. ఓకే, హియర్ ద ఎలిమెంట్ ఈస్ దేర్. నౌ యూ హ్యావ్ టు సర్చ్ ఫర్ ద రైట్ హ్యాండ్ సైడ్. సో వాట్ ఇస్ ద రైట్ హ్యాండ్ సైడ్? 12 అంటే రైట్ హ్యాండ్ సైడ్. జంప్ లెఫ్ట్ లో ఉన్న మాక్సిమం వాల్యూ, ఇంకా షార్ట్ కట్ చెప్పాలంటే లెఫ్ట్ సబ్ ట్రీలో ఉన్న మాక్సిమం వాల్యూ ఏంటండి? 12. దిస్ ఇస్ ద ఎలిమెంట్ యూ కెన్ రీప్లేస్. ఆర్ ఒకవేళ రైట్ సైడ్ వెళ్తే మినిమం వాల్యూ ఇన్ ద రైట్ హ్యాండ్ సైడ్. మినిమం వాల్యూ ఇన్ ద రైట్ హ్యాండ్ సైడ్ గుర్తుపెట్టుకోండి. మినిమం వాల్యూ in the RHS. Or you can say RHS కాదు, right subtree. Okay, right subtree. Okay, minimum value in the right subtree I can replace, or I can replace maximum value in left subtree. So either 12 you can replace as the root node, or either you can replace 25. No issue. Sorry, if you delete this 25 again, and you are just sending, that means this again it will be connected to 3629. Okay. But if you replace this 12, I don't have any issue. This 12 I can send here. 12 I can directly place into 20. Actually, we need to send here level by level. 12, 10 here, 10 is coming now. 12 is going here like this. 20 I have deleted anyway. Okay. So So like this, you can replace either 12 or 25. These two things you can replace. Any choice you can pick up, no issue. Okay. So that is what binary search tree. We have a insertion as well as a deletion. Now I want analysis. My main focus is finding the time complexities and analyzing the these things. Okay. Let us take in this a binary search. Now tell me. Now tell me. Basically, we know very well binary search means it's a searching mechanism, right? In the binary search, what is the best case searching? So if I want to search an element, element in binary search tree, in binary search tree, what is the best case time complexity for searching? I want a best case. 3 cases కావాలి నాకు, okay? Searching, if I want to search an element, జాగ్రత్తగా చెప్పండి. I want to search an element, and what is the best case time complexity as well as what is the best case? First case is best case, and also worst case, and third case is average case. Tell me, can anyone give me answers? Best case. What is the best case, Andy? Suppose I want to search an element 20 only. I want to search an element 20. Best case. Order of 0 ఉండదండి. Okay, order of 1. Okay. Because okay, order ni ఇలా రాస్తున్నా. So it is there. Suppose I want to search an element with 20 only. So what is that? That is the best case, right? I want to means in one attempt I can get it. So the best case time complexity is order of 1. Very good. Order of 1. What is the worst case time complexity, Andy? This is order of 1. I want to search an element in worst case time complexity. What is the worst case time complexity of a binary search? Worst case is excellent, order of n, because if the elements are in either increasing order or decreasing order, so it will take, suppose maximum it will be like a list only. Suppose the elements are, let us take increasing order 10, like this. This is the worst case, right? 10, 10, 20, 30, 40, 50, like this. If I have elements are like this, then what is the time complexity it will take? It will is order of n. Why? Because it will be storing like this. 10, 10, 10 is greater than 20, like this. 20 is greater than 30. 30 is greater than 40. 40 is greater than 50. So suppose I want to search in 50 element in this. So maximum, here it is. You are searching all the elements, all the n elements. In the last attempt, you will get. So this is the disadvantage of the binary search tree also. That's why we are going for ABL tree and remaining all trees, B trees, splay trees. For this, we have a splay tree, and like this, we have different trees. This is the disadvantage of the binary search tree. So worst case time complexity, it is taking like a, so it is order of n. Very good. Average case, and what is average case? Average case time complexity is యావరేజ్ కేస్ అంటే అలా ఉండదండి. లాగ్ ఎన్ అంటే మేబీ ఓకే యు ఆర్ టెలింగ్ యావరేజ్ కేస్ ఇస్ డిఫరెంట్ హియర్. ఓకే, ఒకవేళ లాగిన్ చెప్తున్నారు అంటే మీరు ఎలా అనలైజ్ చేస్తున్నారంటే లాగిన్ చెప్తున్నారంటే ఓకే ఇట్స్ అ పర్ఫెక్ట్ సర్చింగ్ అనుకుంటున్నారు. అంటే అది ఒక్కటే యావరేజ్ కేస్ కాదు. ఓకే, మీరు సపోజ్ ట్రీ అనేది పర్ఫెక్ట్ లైక్ కంప్లీట్ బైనరీ ట్రీ కానీ ఫుల్ బైనరీ ట్రీ షేప్లో ఉందనుకుందాం. మీరు అన్నట్టు లాగిన్ కరెక్టే, కానీ యావరేజ్ కేస్ అన్నప్పుడు అలా ఆ ఒక్క కేసే తీసుకోము ఎప్పుడు కూడా. ఓకే, మీరు ఆ పాయింట్ ఆఫ్ వ్యూలో ఆన్సర్ చెప్తున్నట్టున్నారు. ఓకే, లాగిన్ అనేది బట్ పార్షియల్లీ దట్స్ ఓకే. బట్ యావరేజ్ కేస్ అనేది అలా కాదు. యావరేజ్ కేస్ అనేది ఏంటి, వీ హ్యావ్ టు టేక్ ఆల్ దట్ అన్ యావరేజ్ ఆల్ ఆప్షన్స్, దట్ ఈస్ n by 2 అంటాం. ఓకే, యావరేజ్ కేస్ ఈస్ n by 2. యావరేజ్ కేస్ ఈస్ n by 2. n by 2 అంటే ఆర్డర్ ఆఫ్ n by 2. మీకు ఆల్రెడీ చెప్పాను నేను డా సబ్జెక్ట్లో టైం కాంప్లెక్సిటీస్ ఫైండ్ అవుట్ చేసేటప్పుడు n/2 అంటే ఏంటి, యావరేజ్ కేస్. కాన్స్టెంట్స్కి అంత ఇంపాక్ట్ ఉండదు. ఓకే, సో ఆర్డర్ ఆఫ్ n/2 అన్నా సరే వీ కెన్ సే ఇన్ జనరల్ ఆర్డర్ ఆఫ్ n ఓన్లీ. ఇన్ జనరల్ వీ కెన్ సే n/2 అన్నా ఆర్డర్ ఆఫ్ n ఓన్లీ. సో యావరేజ్ కేస్ ఇస్ ఆల్సో ఆర్డర్ ఆఫ్ n. యావరేజ్ కేస్ అంటే ఒకటని ఫిక్స్ ఉండదండి. We will combine all the possibilities. That's why an average is just sum of this n by 2. సో అందుకని యావరేజ్ కేసు n/2 తీసుకుంటాం. ఓకే, ఇది ఒక డిఫరెంట్ కేసు. ఓకేనా, బెస్ట్ కేసు వర్స్ట్ కేస్ వీ డోంట్ హ్యావ్ ఎనీ ఇష్యూ. సో అదే మీరు ఆర్డర్ ఆఫ్ లాగిన్ చెప్పారు, అది కూడా పార్షియల్లీ కరెక్టే. ఎందుకంటే సపోజ్ ఇఫ్ బైనరీ సెర్చ్ ట్రీ ఇస్ ఏ కంప్లీట్ బైనరీ ట్రీ దెన్ ఇట్ ఈస్ ఏ అబ్సల్యూట్లీ ఇట్ ఈస్ ఏ ఆర్డర్ ఆఫ్ లాగిన్ యావరేజ్ కేసులో. సో బట్ ఇక్కడ ఏంటంటే మనం యావరేజ్ కేసు అంటే ఆ ఒక్క కేసే తీసుకోము, అన్ని కేసెస్. ఇప్పుడు ఈ ట్రీ ఉంది, దిస్ ఈజ్ ఆల్సో వన్ పాసిబుల్ యావరేజ్ కేస్. అలా డిఫరెంట్ ట్రీస్ అన్ని తీసుకుంటాము, దాన్ని సమ్ ఆఫ్ ఆల్ కేసెస్ బై సమ్ చేస్తాం. అలా ఎన్ని చేసినా సరే an యావరేజ్ n/2 వస్తుంది. ఓకేనా, ఆర్డర్ ఆఫ్ n/2. దిస్ ఈజ్ సంథింగ్ అబౌట్ అనాలిసిస్ ఆఫ్ దిస్ వన్. ఓకే, ఇంకా దీనికి ఫైండ్ అవుట్ ది రికరెన్స్ రిలేషన్ ఫర్ ద బైనరీ సెర్చ్ ట్రీ కూడా అంటారు. నేను ఆల్రెడీ ఇంతకుముందు చెప్పాను. బైనరీ సెర్చ్ ట్రీ అంటే ఏంటి, మనం జనరల్గా చేసేది డివైడ్ ద ట్రీ అల్గారిథం ఉంది. ఓకే, టీ ఆఫ్ n/2 ప్లస్ 1. ఓకే, ఇంతవరకు చాలండి. ఓకే, ఐ డోంట్ వాంట్ టు మేక్ యూ టఫ్. సో దిస్ ఈస్ సంథింగ్ అబౌట్ బైనరీ సెర్చ్ ట్రీ. ఓకే, ఇఫ్ యూ హ్యావ్ ఎనీ క్వశ్చన్స్ యూ కెన్ ఆస్క్. అదర్వైజ్ వీ హ్యావ్ ఏ 2 minutes of time. Otherwise, we will close this. Okay. If you have any specific questions, you can ask. Any questions, Andy? Okay. Otherwise, I will close. Thank you for Lalita Jyoti responding for every questions. No, when people are giving replies, that means we can say that whether you are listening or not listening, we can get to know that. Whether you are understanding or not understanding, we will get to know, and we can give some more inputs also based on your replies. That is actually one of the good things. In online classes, you should always give the in chat box. You have to give. You have to respond. Okay. Okay, sir. Shall we close the session, sir? Okay, right. Bye.